Hello and welcome to the fourth section of our full stack Kotlin development course, where we are creating a full stack Kotlin application with Spring on the back end and React on the front end. In this fourth section we will be taking a look at Spring data and how that plays together with Kotlin. We will be introducing Spring data dependencies into our application and then start modeling our JPA entities with the help of Kotlin data classes and see what kind of issues do we arrive into when doing that. Then we'll take a look at Spring data repositories and see how it is a very simple step to add repositories into the application. And finally we'll talk a little bit about inserting versus querying and when to use simple repositories and when to use Spring data query annotations instead. This video will consist of introduction to dependencies, what we need to add to create application with Spring data. We will add a correct Spring data implementation to the project using a Gradle dependency, and then discuss a little bit about the correct database type if we are going to NoSQL or relational root. And finally, when we have all of that figured out, we'll create our database and user for that and set up the proper application properties to run our data connection. Previously, if we jump into our project module, we created a simple build.gradle.kts file, and it only had one dependency in it, which was a Spring Boot starter. This Spring Boot starter gave us the Spring context and all the annotation-based bean definitions with it. Now the next step is to add specifically into our project module a dependency to Spring data, so we can have our Spring data defined within its own scope, in this case our only component that we have in the application, and then we can start using the brilliant Spring data framework. If we think about databases in this case, we know that we went with the reactive way with our handlers of our web application. So our API handler, for example, is returning a mono server response, and that is reactive asynchronous programming paradigm. Then again, if we think about standard MVC applications with Spring, we are usually using relational databases with the help of JDBC driver. JDBC currently doesn't support reactive drivers, and that is something that is not really coming in the near future. That means we need to use the blocking instead of asynchronous, the blocking JDBC driver, and wrap that around so we can start returning these reactive types like mono and flux that we get for free with Spring Web Flux. The other option is to go with NoSQL root and use something like MongoDB or Cassandra, but in that case you will not get the safety of a relational database. As you can probably hear, I'm a big fan of relational databases, and I like the strictness of that instead of a document database. That way we can define our entities and be very strict about it and not care or not be afraid that the data integrity is lost at some point. Therefore, my choice for this application is to use Postgres database as PostgreSQL database as our database provider, and that means we will be using Spring data JPA, and that comes with the Hibernate implementation of Spring data. The other options would be Spring data reactive Mongo or reactive Cassandra, but in this case we'll go with Spring data JPA. So to get started with that, we'll jump into our project module and the build.gradle.kts file within it. The only dependency that comes from Spring framework side is Spring Boot starter data JPA. So if we duplicate this line and add few words behind it, data JPA, we have all the dependencies from Spring side. The other dependency, of course, that we need to add in is the JDBC driver, and in this case, because our database is PostgreSQL, we'll add the Postgres driver in there. The current version is 42.14, and we will be externalizing that property into our parent properties. So let's refactor this one out and add it into a value called Postgres version. And we'll be retrieving it from parent properties with the same name. And our Postgres version, as we saw, is 42.1.4. And in all of its glory, that is actually everything that we need to add to the application. So we added a Spring Boot starter data JPA and Postgres. And if we add the version number in here as well, that will make the application run. Now, to actually configure the database connection and point to the correct place, as you know, we created application properties within our config file in here. This is loaded automatically when you run the application through IntelliJ. If you want to run the application with Gradle using the Gradle wboot-run command, you need to copy that application properties into your resources folder within the API module. That is just the way that Spring Boot and Gradle runs or fetches the properties itself. And the config file, the naming convention, comes from when we are creating a jar file for our application. Spring Boot will retrieve the application properties from within a config folder. But long story short, what we need to do is create a database. So we'll jump into the command line and use the installed Postgres create db command. In this case, we'll create a database called fullstack_Kotlin. That is created, and then we'll jump into the Postgres console to create a user for us as well. The command for that is create user called Jussi, or let's create user Kotlin in this case, and let's add a very finished password for it called Salasana. We'll also want to grant all privileges for this user, so they have the privileges to create tables and do other commands on our database. And now we have our database set up as well. The last thing before we polish up this video, we'll jump into our application properties and add a few more lines in here. So previously we added logging, and now we will be adding our data source as well. The Spring definition for data source starts with spring.datasource, and if we set up our URL, I am running my database on localhost at the moment with port 5432, which is the default for Postgres. So we'll add the URL to be like this, and then we add username and password as well in there. So username was Kotlin and password was Salasana. We'll also add an extra JPA property in here, which we will be using a little bit later. So if we do generate DDL, our JPA provider will generate the tables for us automatically. And that is everything for this.